Mathematics Chapter 16, Cambridge IGCSE. Without much ado, let's begin. Proportion. What do we mean by proportion? Proportion is a relationship that exists between two quantities, okay? Proportion is a relationship that exists between two quantities. One quantity might increase and the other one increase also. So let's say between x and y, if we have two quantity, x and y, if x increases and y also increases as a result of that, then we say that's a direct proportion. Okay, if value of x is increasing and the corresponding value of y is increasing, then we say it's a direct proportion. Okay, for example, if your salary increases and you increase your expenditure, that's a direct proportion. Okay, so but if a quantity increase and the other one decrease, they are not both increasing. And if both of them are decreasing, it's a direct proportion. Either they are both decreasing or they are both increasing, or they are both increasing. That's a direct proportion. But if one quantity is increasing and the other one is decreasing as a result of that, let's say for example, if you increase your speed, the time to reach where you are going will decrease. Because that's inverse proportion. So that's inverse proportion. So for this level, we are only looking at two types of proportion: direct proportion and inverse proportion. One is increasing, the other one is opposite, is decreasing. One increases, the other one decreases. One decreases, the other one increases. That's inverse proportion. Okay, so these are the two types of proportion we're going to look at in this class. Okay, now we start with the first one, direct proportion. We relate it mathematically. We give you a table of values: 0, 1, 2, 3, 4, 1, 2, 3, 5, 10. We choose a given range of values of x, which are called the domains. And then we have the corresponding output value. You know, the output value, y is the output you get from the formula, from the linear graph. Okay, so y is our output and x is our input, which is our domain. Our y is our range. Y is our range, which is the output of the input. X is the input. So this is a relationship, you see, as k by scale factor, which means if I multiply 1 by 2, I'll get what? 2. So if the next values of x is 2, if I multiply 2 by 2, I'll get 4. The next value of x is 3. 3 by 2, 3 times 2, I'll get 6. The next value is 5. 5 times 2, I get 10. If it's 10, 10 times 2, I'll get 20. So which means our output value is a scalar multiplication of input with a scalar number. What's the scalar number? 2. So if you use 2 to multiply the input, you get the output. That's the function machine. That's the function machine. If you use y value also doubles. Y value also double. If you double 1, you get 2, right? That means y value will double from 2 to 4, right? So as you increase it as well, proportional to x. Now let's take a look at that. Okay? So this is the proportionality arrangement. Then you have to introduce the constant of proportionality called k. K is the constant of proportionality. The moment we remove the symbol of proportionality, we have to introduce the constant of proportionality called k. So meaning our function will be written like this: y equals to kx. Now this k is the scalar value you were seeing just now. For this function, the k is 2.5. The k is 2.5, meaning for every increment in x, y will be 2.5 times the value of x. 2.5 times that increment. Okay? For this one, the k is 3. It means for every increment in x, y will be 3 times that value of x. The scalar factor. So this k is a scalar factor that determines the output. Whenever s increases, whatever scalar that is used to multiply x to get the output is called the k. Okay? And is the constant of proportionality. This k is called the constant of proportionality. Constant of proportionality. Okay, if we take these three tables and plot them in a graph, you know how to plot a graph. You have table, right? The x-axis is the horizontal axis, the y-axis is the vertical axis. So if we trace the first one 0 to 0, of course the graph will be on this axis. The next value is 1 to 2, then the value is here. You plot. When you plot for the first one, a straight line. This k factor is the gradient. This k factor is what? The gradient. This k factor that determines the output. Every time we have input, it's being multiplied by this k factor to get the output is the gradient of the function. It's the gradient of the function. Okay, for 3x, if we plot it, we get it. This one is steeper. It's steeper than this. The gradient is bigger, it's steeper. So if you look at this, we have 2.5 as the gradient, right? So every time we plot any of these three tables, this is what we get, okay, when we plot these three tables. Now let's move on. So we say y is proportional to s. It directly means y equal to kx. It means y equal to kx. It means y equal to ks. So where k is the constant and is equal to the gradient of the graph. K is the constant of proportionality, not the symbol of proportionality. This one is the symbol of proportionality, this one, or symbol of variation. When you do like this, is symbol of variation, and yk is the constant of proportionality or constant of variation. Is that okay? You must know the difference. This symbol of proportionality gradient of the graph also. Now, if you have a graph, it's going to be like a bit of a curve like this. It's going to be a quadratic curve. It will not be a straight line graph. If you don't have the negative side. 1 to 2. Why is it 1 to 2? You put 1 here. 1 square is 1. 1 times 2 is 2. Now, you move to the next one. If you take 2 and put it in place of x, you put 2 here. 4 square, you get 16. Times 2, you get 32. That's how they got this 32. If you take this 5 square, you get 25. 25 times 2, you're going to get this 50. That's how they got this 50. Okay? So this gives you a corresponding value, the output value. And then you plot this value, and 2 times 2 times. 2 multiplied 3 times, that's 8. Right? Cube 3, you get 27. Half of 27 is 13 and a half. If you take 3 and put here, the root of 3, the output will be root 3. The root of 4, square root of 4, of course, is 2. So this output is 2. This one is bigger than this, okay? Because if you find square root of this, you get 1 point something. You're not going to get up to 2. Okay, so you get 2. Here, square root of 5, you put 5, or you put 2 point something, and so on and so forth. So you plot this value against this value, and you get all these three graphs. Now you see the first one, like I told you, is a quadratic. You see it's a curve. Every curve, this curve is a quadratic. Okay, it's a quadratic. Even if we plot one side of it, we plot the negative side of it. Okay? Now for this also, this is a cubic. Cubic looks as if you plot the other side, to go down like this. It will go this way. Or it will go like this and like this. Okay? This is a cubic function. Then for the root function, this is what you're going to get if you plot it. So we know how to plot, right? You just use the table of something. So you mark here. 2 on x-axis is root 2. Root 2 is 1 point something. Root 2 is 1 point something less than 2. 3 is root 3. Root 3 is also 1 point something close to 2. 4 is 2. So 4 will touch 2. 5 is 2 point something. If you press root 5, you get 2 point something. Root 6, you also get 2 point something. If you continue like this, so you get this graph. When you plot this graph, you get this functionality. Now let's move on. We say the graph above with x and y coordinate. You know, x is the value, the input value you put in. The y are the output you got, and then you plotted the graph. Okay, this graph is non-linear. The first one we did with a linear graph. These are quadratic. They are non-linear graph. Any graph that is not a straight line is not a linear graph. Okay, so if we have another one, let's say y is directly proportional to s squared. If we have y is directly proportional to x squared, and we make a table, choose values of x, choose the s, what you get for 1 square is 1, 2 square is 4, 3 square, because we are putting the value of x here. 3 square will be 9, 4 square will be 16, 5 square will be 25. You get this, right? So depending on what we did this before. So you get all this value, and then you plot the graph. You plot the graph of s square, only s square, not 2s square. You are plotting s square against y. S square, this one, you're plotting s square. You're plotting this time around, you're plotting s square against y, not the 2s square. So the scalar factor was removed. S square against y, this is what you get, a graph. You get the y values, right? Y value is what? To multiply by half. You get the y value. It now depends on what they want you to plot. If you're plotting s cube against y, you get this graph. Okay, you get this graph. Is that okay for coordinate? Now let's go to inverse function. I think we've explained the inverse function, which we started, we say y is inversely proportional to x. You always write the symbol, and then you say 1 all over. Okay, for inverse, 1 all over. So when you remove the symbol, you introduce the constant, you multiply 1 times k. 1 times k becomes k over x. Okay, the function will be like this. Now let's do some, what usually comes in the exam. Questions like this is what they will bring in the exam paper. Then paper 2, and probably paper 4 also, in the Cambridge IGCSE. You say y is directly proportional to x. This is the first one, direct proportional question, the style of questions that will come in the exam. If y is 7, they've told you y is directly proportional to s. If you put 2 here, so you have 2k equal to 7. To find k, divide both sides by 2, because this here was just a comma. And they say find y when x is 5 now. Now you know your k, you can find y. Now you know your k, you can find y. So you go to come back to the function, y equal to ks. You go to come back to that function, y equal to kx. Now you know the value of k, 3.5. You're going to substitute that value of k, 3.5 into the y is inversely proportional to 1 over x. They will give you something like this, but they will not do the k for you. It's left. They will not give you the value. If y is 5, x is 3, 5, y when x is 30. So what you do, you have to derive introduce the constant of proportionality to find k. So k will be 315. Now find x. So you put 30 here. Okay, 15 divided by 30 is half. It's half, which is 0.5. Okay, it's half because 50 is half of this. 50 divided by 50, you get 1. 30 divided by 50, you get 2. So the answer is 1 over 2, or you put in decimal, which is 0. If you leave it as 1 over 2, you are okay, you are correct. You don't have to bother, especially if it's in not calculator paper. Okay, paper 2. Or you can put 0.5, whichever, it's okay. So that's how we got 0.5. But the question will not stop there. Sometimes they will come and give you something square. Let's look for a question that has a square. You say y is directly proportional. Okay, direct proportion is easy. You just say y equal to ks. Okay, s is 4 square. You know this one is square. 4 square is 16. S square inversely proportional. Inverse, so it's 1 all over. Substitute the value of x here, raise it to power 3, multiply it by the value of y. Because you go to cross multiply, you get k. Good, you have to solve a lot of questions. Okay, with this, we've come to the end of our today's class. Proportion, you have, look at the student assessment. Especially here, they can bring a lot of questions in the exam. Pause this video and solve all of this one. You want to be good in math, you have to solve a lot of math problems. This student assessment 2, pause the video and solve them. They're easy. They're direct. The proportion is variation is very easy. Okay. So with this, we come to the end of our today's class. And thank you for joining us. Thank you.